Aubrey,
Yes.
I know you love a good quiz.
Oh, gosh.
So I thought we could
This early?
Yeah, let's do a quick pop quiz. How far in miles or kilometers, if that's your preferred unit of measure, how far from each other are we?
How far are we away from each other? I'm going to guess 3,200 miles, maybe?
I will tell you, we are 4,400 miles apart. That's 7,000-ish kilometers.
Nice.
Isn't it bonkers that we can co-host a podcast and we are 4,000 miles from each other?
And with not so much of a delay. I mean, sometimes we get mad, right? Like over little things like connections or slight delays. But when you really think about it, we're in two different countries, two different parts of the world having this conversation in real time, and how that has completely changed, like personal life, business life, everything that we can do, right, on a day-to-day basis.
We absolutely take it for granted.
We've come a long way, even since we were kids, right?
Exactly.
So I'm assuming that this is our networking episode.
Yeah, it sure is. You've got it right. So, I'm Michael Bird.
I'm Aubrey Lovell.
And welcome to Technology Now from HPE.
All right, welcome to the third installment in our mini-series, The History of HPE in 10 Objects, where we're celebrating the 10th birthday of HPE by looking back at some of the most important moments in the history of the company and looking forward to where these could continue to lead us in the future. Now, just a quick note before we get started, this episode is being released as a video episode as well as an audio one, so make sure to check us out wherever you watch podcasts too, so you can see myself, Michael, and our guests, and of course this week's objects, which are, as you probably realized, all about networking.
Yes, they absolutely are. Now, from the ARPANET back in the 1960s, which we've discussed on this podcast before, up to the most up-to-date wireless access points, networks are one of the foundations, the fabric of modern society.
So if this is a networking episode, what are our networking objects this week, Michael?
This week, we have object number 5, the Aruba AP52 wireless access point, one of the first wireless access points on the market. Object number 6, I think, is the HP Aruba Networking AP755. And object number 7 is the HP Juniper Networking AP47. Both of these are modern Wi-Fi 7 access points.
So actually, all three of these are wireless access points, right?
Yes, but obviously networking is not just Wi-Fi. There's a wider story beyond that of how networks keep the world connected. And we're covering the full story with today's guest, Stuart Strickland, Wireless Chief Technology Officer and an HPE Fellow who I had the chance to sit down with and discuss all things networking. So firstly, thank you so much for coming on to Technology Now. And we're surrounded by these three wonderful devices. So I wonder if we could just start with, if you could just, the top two here, just sort of tell us what are we looking at here?
Okay. So we're looking at the flagship wireless LAN access points from Juniper and from Aruba. This is the Juniper AP47, and this is the HP Aruba AP755. They're both Wi-Fi 7 access points. Both have 4x4 antenna patterns. That's the most antennas that we put into the system like this for multiple spatial streams. We can talk later about what the Wi-Fi 7 standard means, but they're very similar devices despite having been developed completely independently. They both have a lot of different radios in them. They're both 3-band, 2.4, 5 gigahertz, 6 gigahertz. The Juniper one has a dedicated fourth radio that just listens to anything that's going on in their environment.
You talked about Wi-Fi 7, so can you just sort of give us a bit of a Wi-Fi 7 101? What is it? Is it just faster than Wi-Fi 5 or 6?
It's a bigger number than Wi-Fi 6. So several years ago, the Wi-Fi Alliance, which ensures interoperability among Wi-Fi equipment, decided that it would be a good thing if they made the designations of different generations of Wi-Fi more intuitive. And so they created a scheme. At that time, they decided there was no Wi-Fi 4, 3, 2, 1. They decided that I guess it's almost 10 years ago now, that generation would be called Wi-Fi 5. So Wi-Fi 6 came into being shortly after I came to HPE, was designed to include a lot of features that were really helpful for enterprise. They put the infrastructure more in control of the medium. They allowed us to manage a larger number of client devices to before you could have thought about the network as just a pipe that you were trying to push as much water through as possible. And the Wi-Fi 6 scheme really turned it into a kind of multi-lane highway where we could serve multiple users at the same time. There was an intermediate generation between Wi-Fi 6 and Wi-Fi 7 where we suddenly, after 20 years, got access to significantly more spectrum. So this intermediate phase was basically all the same nice features from Wi-Fi 6, but with an additional 1.2 gigahertz of spectrum, which was, easily tripled the amount of spectrum that we had before.
So presumably, we're talking about, at points additional bandwidth, but at some point, the amount of spectrum is the amount of spectrum. So is it about being a bit cleverer with how you package the data up?
If you want networks to have more capacity, which in an enterprise environment we always do, typically very crowded spaces, lots of clients, lots of stuff going through there. There are basically three dials that you can turn. One of those is that you can get more spectrum, and that's a finite resource. And so the two other knobs are making the modulation more efficient, which each generation of Wi-Fi, and for that matter, each generation of cellular technology has done consistently. Or putting the access points closer together so that each one is able to serve a smaller number of client devices. And we've also done that.
And I guess one of the cool things about Wi-Fi is that in theory you can take a 10, 15-year-old device that has Wi-Fi radio, a smartphone or a tablet, and can connect to the newest devices out there.
Yeah, so a fundamental philosophy of the IEEE 802.11 standard, which Wi-Fi is based upon, is that every new generation should be backward compatible with every old generation, that all of the industry should move forward together, and nobody should be left behind. No device should be left behind. So in principle, we've got here an access point from 2003. If we were to fire this up and you get your latest mobile phone out, it would connect to that, and it would go. The advantage of that is that it decouples the upgrade of the infrastructure from the upgrade of the client device ecosystem. So our customers, when they are thinking about investing in a new generation of Wi-Fi, don't have to wait until the ecosystem of client devices catches up. They can do that right away. The new equipment will support all of the phones and laptops that are in the field already. And then as they upgrade, they'll be able to take advantage of new features.
This is part of the mini-series called The History of HPE in 10 objects. These are objects 5, 6, and 7, I think. So I'd love to look back at how we got here. And as you sort of pointed out earlier, we have this device. Can you tell me what exactly it is?
It's a wireless LAN access point, just like these. It is the Aruba AP52 from July of 2003. It is a dual band access point, 2.4 and 5 gigahertz. That's what we had at the time. It was released in conjunction with the Aruba WLAN 5000 wireless LAN switch, with the idea that these would be deployed in conjunction with switches. They would be managed through a web interface, that you would have relatively dense deployments of these for an enterprise.
And so why is this object so important to HPE's story?
So I think it's important for a couple of reasons, and they don't really have so much to do with the hardware, but with the philosophy that Aruba built around doing wireless networking. So the assumption was that these were going to be equipment that were deployed in what were essentially privately managed but largely publicly accessible spaces. So you think about places like hospitals and schools and universities and hotels, and later large public venues like arenas and stadiums and airports. These systems were deployed on the assumption, which was really the model in a place like a university campus, that everyone brings their own device and we don't know who to trust. And we're going to have to manage this network, this population of client devices in a way that doesn't assume that they're trustworthy. Then it paved the way for bring your own device models, for the zero trust model in a corporate environment, which became the dominant way of thinking about about networking generally.
How did wireless impact the world of networking?
Yeah, so I think that there are in myriad ways.
Yeah.
So first of all, making it possible to participate in the work environment without constraint on your location. You're moving around in that space. And initially that meant you could move around within the office space and still do your work as normal, not worry about finding an Ethernet port. And so we moved from this model where network security was basically a moat around the castle. So if you could get in and hook yourself up, then you could do whatever. To a model which is kind of a panopticon of continuous surveillance, where a device is never trusted, but constantly verified and assigned only the level of access that is appropriate to the current context, its identity, what it's trying to do, and nothing more. And devices are not able to talk to each other unless a policy has been established for that to happen.
So, Stuart, we talked quite a lot about Wi-Fi, but networking isn't just about Wi-Fi, right? Like there's other things. Like, what are the challenges that have to be addressed when it comes to networking in general? I suppose when we're thinking about our organizations, particularly with the challenges that are brought in from having these fancy wireless networks.
Right. So, you're right. There are a lot of components in the networks. The networks are diverse. The networks are managed in different ways. The requirements of the local venue are different depending upon what kinds of client devices it serves. Almost all of the networks that we operate in are heterogeneous in the sense that they involve a fixed network and a wireless network. Almost all of them will involve access to some compute and storage resources that are local. Maybe they're local because of security reasons. Maybe they're local because of a need for the interaction with them to be low latency, quick turnaround time. They're sometimes managed by what we call a controller system, local in the building, but they're sometimes managed in the cloud.
This device, as you said, was from 2003.
2003.
And these devices are from 2025. So we've got a gap of nearly 23 years between them, which is pretty staggering. I'd love to just talk about the way that we think about our networks has changed in that period of time.
It came at a point that I think, strangely enough, we were ready for. So we were ready for providing access to public networks in a way that would be secure, even though the link wasn't necessarily secure. You, as an individual, could be confident in the quality and security of the network that you've set up in your home. But we, as a corporation, as your employer, couldn't necessarily be confident in that. But we needed you to get your job done, and we wanted you to talk to your colleagues, and we wanted you to access confidential documents that were part of your job. So the security framework for setting up secure tunnels between devices where the endpoints were trusted, but what was happening in between was completely unknown, that was already pretty well established.
So I think this feels like it leads really nicely into zero trust. I mean, we've talked about it on the show before, but can you just sort of quickly explain zero trust?
The framework of zero trust is based on the assumption that I can't take for granted that any device is trustworthy. I must verify that.
Even a corporate device?
Even a corporate device. Any device. The zero trust is you start out and you actually remain untrusted on my network. But I can find out some things about you, and I can limit some of your access in a way that keeps you from becoming dangerous, no matter what you are or what you're trying to do.
So, like, I don't know, if you're accessing it from a device or a location you've never accessed before, it maybe asks you to sort of keep putting in credentials.
Yeah, I think it's less likely to ask you to do something that's problematic for a couple of reasons. One, because, well, I've just alerted you that I have some suspicion. And secondly, if you're doing something that's just normal, then that becomes very tedious very quickly. So we're more interested in detecting behavior that is likely that raises the risk level and then leads to greater attentiveness and maybe some guardrails being put around the device and a continued observation. What we want to be really careful of, and this is something that AI is very good at, pattern recognition, and we use techniques like machine learning and neural networks to affect that. So these access points are collecting huge amounts of data. Some of that is patterns of traffic, whether that's the content of the traffic or just how the traffic is varies over time. If, for example, we have a very crowded network with a lot of activity and people on it, it would make sense, to have all the access points turned on and operating at full capacity on the most efficient configuration possible. As the network starts to become more sparse, people start to go home, we can turn off some of the access points. You wouldn't need to know when are going to be the busy times and the sparse times. I don't have to know that in advance. The network can detect that.
And these two devices, perhaps differing to this device, these two devices aren't just giving you access to a network. In theory, they're collecting lots and lots and lots of data that can be then used to.
One of the things that we're really looking at a lot now is that as these things have grown, they've got a lot more processing power in them as well.
They're heavy, aren't they?
No, they're quite. I mean, so they are bigger, as you can see, and heavier than they were 20 some odd years ago.
Yeah.
But they have a lot of processing power in them individually. And one of the things that we're looking at is how much sense does it make to have elements of artificial intelligence that are distributed and done locally in the access point versus collectively in some sort of data center?
Right. So sort of computing at the edge and these becoming the edge computers.
The very edge is, well, I guess the very edge is the airways between the access point and the client device. But the last place that we have a chance to really completely control it is what's going on in the access point.
So coming into land then, what does the future of networking look like? I mean, when we're talking about access points, these are Wi-Fi 7, right? So Wi-Fi 8, 9, 10... 20? Will it just keep going up?
So whether there is something that eventually gets designated as Wi-Fi 20 probably will be determined by non-technical marketing decisions. I think that, I can say with great certainty where Wi-Fi 8 is going because we are already in the middle of defining that in the IEEE in 802.11. It's going to be a while before we see something as dramatic as we saw on Wi-Fi 6, which was really a whole suite of features that greatly benefited dense deployments in enterprises where the infrastructure controlled, and Wi-Fi 6E, which introduced an enormous amount of additional spectrum.
Do you think we'll see the death of Ethernet?
I'm not going to prognosticate the death of Ethernet. Because, well, for one thing, there are two Ethernet ports on the back of each of these. They're each 10 gigabit per second ports, and it's awesome. And we could use faster, higher capacity ports in the future. And I hope that standard continues to evolve.
Stuart, thank you so much for joining us on Technology Now for our mini-series, The History of HPE in 10 Objects. It's been an absolute pleasure speaking to you. I feel like I've learned a lot.
Likewise, it's really a pleasure to be here.
That was a great interview. I really enjoyed speaking to Stuart. The whole interview was far longer than what you listened to because I just kept asking more and more questions about things.
To your point in the beginning of the episode, Michael, we talked about taking things for granted, and it just really shows you how much we do rely on networking, right? Like networking is essentially experiences that we have, whether it's through work, whether it's through personal use or college campuses or just all the things that we do with our devices to advance the way we live and work, which is what we like to say.
One of the things that I found most fascinating about the interview was just sort of walking through the impact that basically the introduction of wireless networking has had on the way that we think about our networks. I don't know if you really remember the days before Wi-Fi, but I remember the first time I interacted with Wi-Fi was at school. And we had these laptops that had these massive dongles plugged into the side, and we could walk around the classroom with them and still be connected to the very slow network.
Yeah.
And it was at that point that actually you weren't tethered to an Ethernet port. You could move around.
Yeah.
And I think at that point, the sort of walled garden that you could create with your network sort of disappeared, because somebody could sit in the car park with a laptop and connect to your network if it wasn't secured properly, which then brings us really nicely into the conversation we had around zero trust.
Yeah, absolutely. And especially with things like that, as the world has become more mobile and us being able to freely move about with this technology, it's obviously like the number one thing you have to address, especially if you think about enterprises and businesses trying to protect their network.
The other thing that I thought was quite interesting was that when we had a conversation about networking devices not just being networking devices, when we chatted before, Stuart and I were talking about how some of the devices could have sensors, maybe temperature sensors, and maybe those temperature sensors could make a decision on something, which could do something.
Well, we're already seeing that, right? That's already happening in terms of like the ideology of Internet of Things, right? But it's just, what's that next level that we're going? I feel like the infrastructure is already there. It's just a matter of the innovation within that infrastructure and how that progresses, right?
Now, we have talked a lot about the different features of networks and Wi-Fi, but I do think one of the coolest of them has to be Wi-Fi sensing. Have you heard of Wi-Fi sensing before, Aubrey?
I would assume that probably means like recognition, facial recognition, things like that.
Oh, I don't think you're too far off.
Okay.
But anyway, I spoke to Stuart about it. So here's Stuart just telling us a bit more about it. So, Stuart, I've heard of this phrase, Wi-Fi sensing. Can you explain what it is? Why is it useful?
Sure. I'll tell you about it in a couple of different ways, and we'll work our way around. It's basically a Wi-Fi access point looking at changes in the radio environment and making inferences from those changes about what's happening. So, for example, the Wi-Fi signal will bounce off of human bodies, off of doors, off of your hand, and at a very basic level, we could detect, for example, if there are 1 or 5 people in a room. At a finer grain, there's a hope that eventually it will be able to do things like detect your hand gestures or the nodding of your head, so that, those can be part of your user interface or interaction with objects.
How cool is that?
That is really cool, for sure.
Yeah.
It kind of reminds me of like when you think about the traditional consumer technology that we have, like thinking about the recognition that you have when you have one of these like smart doorbells, right? That tell people, and it's like unfamiliar face or familiar face, and actually can track movements.
The possibilities for this, I think, are endless, and they are quite cool. So it was really exciting.
Okay, so that brings us to the end of Technology Now for this week. Make sure to come back next week for our final installment of the History of HPE in 10 Objects, where we will be talking all about new frontiers. Sounds very exciting. And thank you to our guest, Stuart Strickland, and of course to our listeners. Thank you so much for joining us, as always. And if you've enjoyed this episode, please do let us know, rate and review us wherever you listen to episodes. And if you want to get in contact with us, send us an email to technologynow@hpe.com. And don't forget to subscribe so you can listen first every week.
Subject line for the email, prognosticate.
Ooh,
That was
fancy.
a word Stuart said in our interview. And if you can spell prognosticate, well done. Anyway, this episode was produced by Harry Lampert, Izzy Clark, and Spencer Trinwith, with production support from Alicia Kempson-Taylor, Becky Bird, Anissa Mitri, Rahil Ali Mohammed, and Renee Edwards. Our video editor was Mikey Nissenbaum, and as always, our theme music was composed by Greg Cooper.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, and Jacqueline Green. And our social media designers are Alejandra Garcia and Ambar Maldonado.
Technology Now is a Fresh Air production for Hewlett-Packard Enterprise. We'll see you at the same time, the same place next week. Cheers.
Cheers.